Have you ever wanted to recreate that classic arcade feel where timing is everything? Today we're going to build a depth charge mechanic from scratch in Godot 4.6. You'll learn how to lock a player to the water surface and rain down physics-based chaos on unsuspecting fish below. Thank you to our newest Patreon member, Full Fist Anger. Your support makes these deep dives possible. Now this is the depth charge project. We're not just going to build a prototype that dies on the hard drive. We're actually going to launch this one on itch. I'll show you how to do that and be able to play it through the browser. We're going to build a side-to-side shooter where the z-axis is flipped to the y-axis. We're going to fight gravity instead of distance. We're going to cover player movement, project instantiation, and basic enemy AI. I'm Spaghetti Syntax. Let's get building. Now, before we place a single pixel, we're going to set up our communication lines. We're going to use a SignalBus. Now, this is a global node that listens for events, like the fish dying or a score that's going to update. So our objects don't have to talk to each other directly. All right, I'm here in a brand new project. First thing I'm going to do project settings. I'm going to change the window size. I'm going to run with 1280 by 720. And then in the input map, we're going to set up some movement actions. First, I'm going to use move left, move underscore left, and then move underscore right. We're going to go left and right. And on the left, I'm going to add input is going to be A. Move right, input is going to be D. Enter. And then we also need a drop. And the drop action is going to drop our depth charges. The drop we're going to use spacebar. I'm going to close that. A couple of folders here. I'm going to right click on the root folder, create new folder. We're going to make a scenes folder. Right click, root folder, create new folder. Going to be a scripts folder. Right click, root folder, create new folder. Going to be a auto loads folder. I'm actually going to drag and drop this into the scripts folder. Press OK. Now our scripts folder has the auto loads in it. And in our auto loads folder, we're going to right click, create new script. What's going to be called is a SignalBus. And press enter. That should open up. I'm going to delete all this boilerplate code here. And all we want to do here is we're going to define our global signals here. Global signals here. Signals here. And this is going to be first signal we're going to use is signal on fish. I'll go and save that. Now we need to make this a global singleton, basically. So we need to go into our project settings. We're going to go into our global section, and there are a little path icon here. We're going to go into our scripts, auto loads, SignalBus, open. Then we're going to have this SignalBus node name, just like this, big S, big B, no space. Go and add. And now we need to make sure this is enabled. And now we have a SignalBus auto load. Go and close that. Now you might notice this yellow icon here. It says this is not used. We're not actually going to use this signal in this class or script at all. How do we fix that? Well, simply, we just go above it. We say at warning, ignore. The warning we're going to ignore is unused signal. Right there. Just have this right above it. I'm going to save it. That gets rid of that caution for us. Just basically tells Godot, trust me, I know what I'm doing. Now, the SignalBus is available everywhere. Any script can emit signalbus.onFishCaught.emit, and any script can listen to it. No get parent, no get tree. So it's pretty clean. Now let's build the player. We need strictly typed movement locked to the water surface. We need a player scene. So in our scenes folder, I'm going to right click, create new scene. And then I'm going to switch the node here. And I'm going to use character body 2D right here. I'm going to make sure the scene name is called player. Player.tscn. It'll change our root name for us. We press OK. And now we have our player scene. We'll go into our 2D section. Now to our player, we're going to right click and add a child node, a sprite 2D. And then we're just going to use the icon right here, little icon guy. And then we're going to change the size of it. We'll just use 0.5 in the scale of the transform. 0.5. Zoom in a little bit. And then we need a collision. So we're going to add a collision shape 2D. We're just going to use in the shape and the inspector. I'm going to use a rectangle and then make the rectangle match the size of our player. Easy peasy. Can save that. We also need a marker 2D to mark where the depth charges will drop from. So our root node player, right click, add child node marker 2D right here. And then we're going to use this move tool here. I'm going to bring this down to the bottom. You zoom in, you can see the red line here. So that is where the depth charges are going to fall from. I'm going to rename this marker 2D just to make it more explicit, drop point. Now we need a script on the player root node. Right click, attach script. We'll just put it in the scripts folder. Go back in our path, root here, scripts. Now in our scripts folder, player GD is fine. And keep all the default, create. Well, we're not going to use any of this really. Let's just get rid of all this. We'll write our own. All right, so first thing we're going to need here, we'll use the const speed. And it's going to be a type float. And we're going to go with 400 is good for now. Then we need a constant water level. So we know where the water level is. So when we're spawning our fish, they spawn below the water level. This will be const water level. That's going to be a float 150.0. Great. Then we need a scene, which is going to have our projectile. So our depth charge. So at export, var projectile scene. Going to be a packed scene type. Okay. A packed scene, if you hold control and click, it's really just an interface so we can instantiate a bunch of these into our world scene. And then we don't have to worry about hiding or anything in our world scene. We'll be able to instantiate, queue free delete, and then keep instantiating that same scene over and over again. And back in our player script, so after our exported scene, which we'll put in once we make our projectile scene, we need a ready function. So function ready. You can tab to autocomplete that. And then the first thing we're going to do is set the player's position to the top of the water. And the top of the water level is 150. So the position, since this is attached to our player, position is our player. So position.y is just going to be the water level. In case your player gets somewhere else, we'll automatically teleport to the top of the water. And after the ready function, as you have a couple times, we're going to make the physics process. Delta float, tab to autocomplete. The first thing I need to do is store the direction. And that's going to be of type float. And that's going to be the input.getAxis. So we know which direction that our player is moving. And the first things we need to do is our move left that we made. Move left. And the axis move right. I'll make this bigger so you can see it better. So now that we have our move left and move right input.getAxis, we know where the player wants to go. So then we just say if the direction is not null, we want to set our x velocity to our direction times the speed we want to go. Great. Whoop, there it is. And then else, so if we don't have a direction, we want our velocity dot x to move toward, so it's not instant stops. It'll glide a little bit. So our velocity makes the motion more smooth. Velocity.x, then we use what do we want to get to? We want to get to 0. What do we have? Our speed. So if you hold down control, click move toward, you'll see it's move toward is from where you want to go and the amount that will not go past 2. So we'll go past the 400 we set it to. So there's no instant snapping. All right, so now we have that. After that, we need to set the water level position dot y equals water level. So make sure we always stay at the water level. It's more like a safety check. And then after that, well, we're not going to go anywhere if we don't use move and slide. It's very important. The move and slide allows us to multiply our directional speed times like time.delta time, which is important because you have a better or worse graphics card, it'll change the speed. We want it to be consistent across everyone's computers. So after move a slide, we're going to use our drop command. So if input dot is action just pressed, and then we're going to use drop. That's going to be our space bar. So we can drop our projectile for our depth charge. And then we're going to write a function called drop item. Enter down a couple times, and I'll write this function called drop item. It's going to be return type void. Then we'll enter down into the function. For now, all we're going to do is print projectile dropped. There we go. Let's save that. You reached a checkpoint. Go ahead and run your game with the F6 or the film reel icon and press the spacebar as fast as you can. Notice a problem. You can spot as many charges as you want as fast as you can press the spacebar. That's not really a mechanic. That's going to be a mess and not really a challenge for the player. So your challenge, add a cooldown. Modify the drop item function in the player GD script so the player can only fire once every 0.5 seconds. So go ahead and pause the video and try to solve this using an await timer and a Boolean flag. All right, hopefully you gave that a try. I'm going to give you a couple hints here and see if you want to pause it from there. The first thing you want to do is the Boolean flag. So at the top here, we're going to add a variable. Beneath the exports variable, and call it can shoot. It's going to be of type bool, and we're going to start it with true because we want the player to be able to shoot right away. So now we have that variable, and go back down into our drop item function, and we can go and get rid of this print statement. Don't need that anymore. Now we just want to check if we can shoot. So if we can shoot, which means it's true. Well, we go into this, and the first thing we want to do is set can shoot to false. So we're going to set this to false so we can lock the firing mechanism. Lock firing. And if you know how to do the await timers, go ahead and pause it now and give that a try and finish this function out. All right, hopefully you gave that a go. Let's do it together. What we're going to do, we'll do the print statement back again, do projectile dropped. So we'll be able to see the difference now when we add this await timer in. As before, it was as fast as we could. Now it's going to be the wait for as well as many seconds as you want to put in between. We're just going to do 0.5. Wait for 0.5 seconds, then unlock again. So how do we do that? We're going to wait, and you get the scene tree, and then we're going to create a timer. And the timer is going to be for 0.5 seconds. And then once the timeout signal hits, which means this timer has run out, we're going to turn can shoot back into true. Now, so this can shoot will be true. We set it to false right when you get in here. Then we're going to drop the projectile. But then we're going to make the player wait for 0.5 seconds. So it's going to stop here, wait for this to clock down, and then set it back into true. So no matter how fast you press the space bar, it's going to make you wait 0.5 seconds. Now the projectile and the fish we're going to create are simple area 2D objects. But there's a little bit of magic. When they collide, we don't want to try to find a score label. We're going to actually just shout into the void using that SignalBus we created. So first thing we're going to do is create that projectile. I'm going to save this script if you didn't already. Scene, new scene. And it's going to be other node. We're going to use area 2D. Here. Make this a little bigger. I'll go back to my 2D scene here. Right click, add child node, add a sprite 2D. And then we also want to use the icon. Keep it real simple. And the texture there. And the transform on the scale on this one, first we'll make this projectile 0.2. I'll zoom in a bit here. I'm going to scroll down to the visibility, self-modulate, click in there. I'm going to make this red all the way up. Just like that. So we have a red projectile. Then we also need a collider. So right click on the area 2D, add child node, collision shape 2D. And for this, we're just going to use a circle. So in the shape, with the collision shape selected, we use a circle shape 2D. And then we can increase the diameter to cover the entire sprite. All right, I'm going to save this scene. We'll rename this to Projectile. There we go. Now we can save the scene in the scenes folder as Projectile. Now we just need a script. So on the root, add script. In the scripts folder, back up on the root path, scripts as Projectile is fine. Create. We get rid of these boilerplates. Now we want our projectile to sync. So we need a sync speed. So we use it as a constant. We don't want this to change at runtime. So we use a const called sync speed with a colon, and then it's going to be type float. And then our sync speed is going to be 200. And then we need a physics process so we can actually have the projectile sync. So func underscore physics process tab to autocomplete. And in this, we want it to sync not left and right. We want it to sync down. So that's going to be the Y, not the X axis. So position dot Y plus equals sync speed. I'm going to multiply that by delta. Delta because we want it to be frame rate independent. We don't want it to be dependent on how good your computer is. We want it consistent across all players. We want to say here, if the position dot Y is greater than 800, which means it is below our play window. So we want to get rid of it. We don't want these to stack up in our game. It'll eventually slow it down, regardless how small they are. So once it disappears off the screen, Q free. Q free. There we go. So we get rid of it. Great. And now we need to connect a signal here. I'm going to save this script. And in our projectile here, we need to go into the signals tab over here. We want to connect the area entered so we can detect when we hit a fish. And double click right there, area entered, connect it to this script we're working in, the projectile script, and continue or connect. Now we have our script connected. Now we need to check if it's a fish. So we're going to use that as a group. So the groups are great because they can keep things really organized, kind of like tags, if you're familiar with those. So I'm going to check here, just if area that we collided with, because this passes in the area. So we're going to check that area if it is in group. And the group we're going to check is fish. We're going to create that group when we create our fish. So now that we know that we have a fish we've collided with, well, we want the area dot die. So we're going to kill the fish. What does that mean? Well, we're calling this function that we're going to write in the fish object. Now we'll write that function a little bit, but this just assumes that the fish has a die function. Make this bigger. Has a die function. This doesn't know it does, it just assumes it does. So if you don't have a die function in your fish, well, this will throw an error. So you got to make sure you're accurate on that. And then we want to get rid of our projectile if we collide with the fish. Just like we did when the projectile went out of the screen range, we just call Q free. Great, now that we have a projectile, we can now save the script, go back to our player script. Now we can update our drop item to actually use the projectile. So now instead of just printing a statement here, well, we can do var item node 2D equals projectile seed. Now I'll make this bigger, zoom in a little bit. Now we're creating a variable of type node 2D. If you specify your actual types, Godot likes that better and will run faster. So do that wherever you can. And this node 2D is going to be of type projectile seed. Now you might be thinking, well, our projectile is an area 2D, not a node 2D. So why are we doing it as a node 2D? Well, you can think of node 2D as a vehicle. The area 2D is the car. So when you type var item node 2D, we're telling Godot, I don't really care what specific type of 2D object that this is. We just need to know that it is a 2D object that exists. And then it really just future proofs too. So if you change your projectile into, say, a rigid body 2D, well, it's also a node 2D because it inherits from node 2D. So then it won't break your code. Basically, since every 2D object inherits from node 2D, and we just really need to access the position. We don't need anything else. If we ever need to swap it to anything else, the code won't break. That's it. Great. Now that we set the projectile scene, we want to instantiate it, which means we're going to bring it to existence. And then we just need to get the tree that we're in, get the tree, scene tree, and move the current scene. And we want to add a child to that scene. The child is going to be, well, the item that we just grabbed in the projectile. So spawn that projectile where we want it to. Well, where do we want it to spawn? Item.global position. We want to actually spawn it in our drop point, which is our marker we set when we made our player, the bottom center. So the drop point, make sure this here is actually as it is in your game. Make this smaller. Remember our player here. This is the drop point. That's what we're accessing right there. So drop point, zoom in a bit. Drop point is global position. So that I can get that anywhere it is. Now that we can shoot the projectiles or drop them, we're going to create the fish. So we need another scene. It's going to be a new scene. And I'll make this smaller so I actually see it. And then we need another area 2D. Use the other node. Area 2D. There we go. Go to my 2D scene here. Inspector. Now in our area 2D, this is going to be our fish. Okay. And just like our projectile, we're going to add a child node sprite 2D. Once again, we're just going to use the icon for simplicity's sake. And then the size of this fish, we will do 0.35. There we go. Right in the middle of the other two. It's bigger than the projectile, but smaller than our player. Color-wise, visibility, let's just do self-modulate. Let's do green. We'll pull this blue and red all the way down, create a green fish. Perfect. We also need a collision. So right-click on the root node, add child node, collision shape 2D. We're going to do here is just do another circle shape, and then increase the diameter all the way to the edges. All right, go ahead and save that in the scenes folder as fish. Save. So this is a very important part, is not to forget to put this in the group. So we are finding this fish by the group in our scripts. And our projectile is finding it in the area is group fish, spelled just like this, lowercase fish. So we need to go into our fish here, and we need to go into the root folder, or root node, and then go into our groups tab over here. I'm going to put plus signal here, create a new group. I'm going to make it global, make sure that's selected on, so we can access it from anywhere, lowercase fish, just like that. And now we have a group named fish. Now that's check marked. You'll see the square box with the circle means it's in a group fish. So now our projectile can find it from here. So it's going to see that this area is a fish, and we're going to call this dive function on the script we're about to write, and then kill the projectile. Great. So back in our fish, we're going to right click, we're going to add that script, attach script in the scripts folder, not the scenes folder. Go back up into the script. There we go. Fish. Go and open it up and create. We're going to get rid of this boilerplate here. First things we need is the speed of the fish. We're going to use a variable speed, and then it's going to be a type float, and we'll set this at 150 for now. And the direction we want, well, we're going to start with the direction type int is to 1. And then to get those fish moving, we need a physics process. So function physics process, tab to autocomplete. And then we need the left and right for these guys. We're not going to go up and down. We're going to do position dot x as your left and right. So we're going to plus equal the speed. Then we multiply that by the direction. And then we use delta to make it frame rate independent. Multiply, not the other one, times delta. I can type. There we go. Now we need to check if our fish are off the screen. So depending on if you're following along with the same screen size as I used, use position dot x is greater than 1500, or the position dot x is less than negative 200. So it's about 200 pixels on each side of the screen that they've disappeared on. They will disappear. And how do we do that? Well, they're not disappeared yet until we use Q3. There we go. Now that'll clear up our memory, so we don't get too many things we can't see on the screen. Now, the most important bit, that die function we said to Godot that we have. So we need to fill that promise function, die, return type void, call it into the function. This is the magic moment here. So the magic moment where we're just saying into the void saying, oh, we're a fish, we've died. Well, we use this SignalBus right there that we created earlier. And we use on fish caught is the signal that we used. And we're going to emit that signal. Now the SignalBus knows that there was a fish caught, doesn't care where, when, who, just that it was. Now we're going to Q3 and get rid of the fish because it doesn't need to exist anymore. The SignalBus knows what to do now. Great. Now that's an example of what you call loose coupling. Now we need to build the world. We'll need a sky, an ocean, and a HUD, heads-up display. Heads-up display script will be responsible for listening to the SignalBus. Right, I'm going to save this script. Now we're going to make a new scene, new scene. It's just going to be a 2D scene here. I'm going to rename this to just main. Good enough for now. Then we need, I'll go back to the 2D, see what's happening here. Make this smaller, go back to the inspector. I'm going to right click on the main root node. I'm going to use a color rect. Color rect. And this one is going to be the sky. So we'll rename this to sky. The size we're going to use here is we're going to use the layout, transform, and then the size we're going to use to match the viewport window we have of 1280 for the X. And then we want to go down to the 150 because that's where we want our water to start. So our Y is 150. Okay, and that's going to be our sky. Now we use a light blue color here. So I can go up to color, change this to a light blue. So I can bring all this red and green down, bring this up to a light sky blue color, however you want it. And we'll go with that for here. All right, and save that scene as main in the scenes folder. It's always good to keep your saving often. You never know. Right, now we need the water. Right click on the main root node, another color rect. This is going to be the water. Rename it to water. This one, and then layout, and our transform, and our position. I'm going to move this down to the 150, where we want it to start. Position, Y, 150, just right there. Now the size, well, we want the same width as the scene, which is 1280. And then we want the size, which is the rest of the height here, is 570. There we go. You just get that by minusing the height of your viewport minus the 150, and you'll have the rest of it there. So if you changed yours or didn't follow along with that, you want a different size, well, you can just do the math, just equal minus whatever you have here. Great. Now we have this. Well, we don't want white water. We want blue water. So we'll do a darker blue here. Let's keep it nice. That's a fancy dark blue. We'll just keep that. And then in the main screen, we want to actually instantiate the player. So on the root node, there's a little chain icon here. We'll click on that and instantiate the player. Now we have our player here. We'll put our player where we want our starting point, like right in the middle here. So the position of the middle, we'll need to change the transform position of the middle will be divided by 2, 1280 divided by 2, 640. And then we want to start on the 150. There we go. Now our player's right in the middle. I go and save the scene. And now we need to add a timer. So on the main root node here, right click, add child node, timer. Right here. And then we're going to have this timer auto start here. And then the wait time is going to be, we'll do 2 seconds. Now this is going to be the timers for the spawns of the fish. So every 2 seconds, it's going to spawn a new fish. That's what we're going to use this timer for. Great, now we need our HUD, our heads-up display. So on our main root node, add child node, we use a canvas layer. Right there. And rename this to HUD, like that. And then we want a label. Right click, add child node, label. This is just going to rename to score label. There we go. Now I'll anchor this here into the top center. And then we can change the text to score 0. And then for good sake, we'll center horizontal alignment to center. Make sure everything's nice and even. All right, go ahead and save the scene. Then we have our score and our player, water, and sky. We need the main to have a script. The main root node, attach script. Not in the scenes folder, we want to put it in the scripts folder. Then we have our main, open, and create. Great. Go ahead and delete the boilerplate. Now you want access to our fish scene, so we can actually spawn our fish. Use an export there. So at export var fish scene. And that's going to be of type packed scene. And then if we save it here, you can actually go see now we have our fish scene in our inspector. We can go into our seeds folder, drag and drop our fish into the fish scene export. Now our main knows which fish we want to spawn. Great. Now we have that. We also need to access our score label. So we just do that. We can take our score label, drag and hold control and drop. And it'll autocomplete all of this for us. So our path is correct. We also want to know what the score is. We're going to start the score at the new variable, score of type int at 0. There we go. Now we just need to start with the ready function. Function underscore ready, tab to autocomplete. The first thing we want to do is wire up the spawner. Wire up the spawner. Then we do that with the timer. So make sure our timer is still named timer. Then we can use buddy symbol timer. And we're going to access the timeout signal. And we're going to connect that with our function. We're going to write on timer timeout. Great. And then I'm going to enter down a couple times and write that function called function on timer timeout. Right? And it's going to of type return void. So it's not going to return anything. We're just going to access the function. And in this function, well, we need the fish. So we're going to access the fish of type area 2D equals fish scene that we have from our export variable up there, and we're going to instantiate it. Now we have our fish. We're going to pop it into the world. We're going to add that child to this main root node. So we can just use add child because this is attached to the root node. And we're going to add the fish. We don't want our fish to spawn all in the same spot. We want to randomize it. So enter down a couple of times, we're going to randomize the spawns. So when you get the height of the water we have, spawn y, type float. Or we're going to use the random range, which is random f. So it's random float range. And then we're going to give it a range, underscore range. And in this, we're going to lock it into a 200 from 600. So we want it to spawn in between the 200 pixels, which is below our 150 water line, and 600, which is above the bottom of our window. We don't want it spawning in the sky or below the window itself. Now we have that random range. We want to say, well, do you want it to spawn on the left side or the right side? How do we do that? Well, use var is left. We'll do that. That's how we're going to use a bool to say if it'll spawn on the left or the right. And how do we do that? We use a random f again. And we're just going to use the random float, which will return a number between 0 and 1. And then we check if that random is greater than 0.5. Well, if it is greater than 0.5, this bool will be true. If it's less than 0.5, this random's going to return. It's going to be false. And we can use that by saying, hey, well, if is left is true, like that, well, our fish.position, like that, we're going to spawn that in a vector 2, -50. So we're going to spawn it on the other side, on the left side of our screen here, -50, and the spawn y, which is the height. So spawn on the left side of the screen at whatever randomized spawn y that it got as well. And then we're going to change the fish.direction is to 1. So it's facing right. That's what our 1's going to be for. So else, say, if the left is false, well, we want to put it on the right side of the screen. So the fish.position equals vector 2, and that's going to be on whatever is the outside of your window. Ours is 1300, just like when we got rid of the fish, if they swam out of range. So the 1300 is where it's going to spawn and start swimming to the left. And then we use the spawn y again to say which height we want to spawn the fish at. Now we want to make sure, say if you have a sprite that faces left or right, well, the fish.direction is now going to be, let's zoom in and make this bigger. Fish.direction on the bottom here is going to be -1. So the opposite of the other one, -1. Perfect. Also, now that we have the direction, if you actually have the sprite, you want to flip it. So if you have type, that's actually direction specific. The icon is not, but future proofing, or say you added your own fish, flip horizontally, your fish needs to be flipped to true. Now your fish will be facing the right direction. Great, go and save that. I'll make this smaller. And then you'll notice also in our player here, let's go back to our player, there are projectile scene. We actually never set. So we actually got the export for the projectile scene, but I forgot to pull in the projectile scene and drop it into the actual player script. Now we have our fish logic. We also need the score. So in order to update the score, we're going to actually log into our SignalBus again. I'm going to wire up the SignalBus to say the fish got caught. So update the score. So SignalBus.onFishCaught is the signal we used. We're going to connect to that. And we're going to write a function called update score. Like that. And enter that a couple times. Write this function update score. It's going to be return type void. Go into that, and then we're going to update the score just by 1. So score plus equals 1. That'll give us 1 point. We need to update the actual label as well. So the score label dot.text. You want to access the text in the inspector, and we're going to change that to score colon and use the modulo here, S. And the modulo S is just a placeholder for a type string. So the string we're going to actually use, we're going to make a string, is the modulo, again, score, right here. So I'm going to turn this score into a string and then print it in the text of the score label. Go ahead and save that. All right, now that we have the fish all connected and the score connected, we can use this on the main here. As you're in the main, we made, go and use F6 or this film rail icon. We'll click that, give us a test. We spawn right in the middle. We can move left and right. Our score is 0. Then we press spacebar, we can drop a charge. See if we can hit one of the fish. Boop. There we go. Score is 1. Score is 2. Oh, missed that one. Score is 3. Perfect. So the player drops a charge, the charge hits the fish emits a signal, and then the main scene hears that signal and updates the UI. So this architecture allows you to expand easily. We're going to add a sound effect, so you can just use an audio node to listen to the signal bus with the on fish caught. Particle effect, same thing. No need to change that fish script ever again. It's clean code, clean game. We built a solid foundation using singletons and signals in Godot 4.6. In the next video, we're going to polish this up. We're going to add some boundaries so the player can't leave the screen, sound effects, and we're going to make the fish movement smarter with sine waves. And if you found this helpful at all or fun, leave a comment what your Godot game dev goals are. So please like and subscribe, hit that notification bell. It really helps out the channel. Thank you to all our current and past Patreon and Coffee members. Your generous support keeps the channel moving. If you want early access to tutorials, source code, or suggesting future tutorials, please consider becoming a member yourself. The links are in the description. I'm Spaghetti Syntax, and remember, always stay curious. And I'll see you at the next checkpoint.